Okay. Wouldn't it come? You can see the questions, no? तो यहाँ पे चैट आएगा? Watching now. We are live. We can start, but ये तो delay हो रहा है कुछ. अच्छा. Good afternoon to everyone. Please ask question. Otherwise, we shall pick up one questions and discuss which has been actually forwarded into the forum. It seems to me that you don't have any questions. Okay, let us take one questions. I received in the forum. That is, why thyristors is not connected in series with the capacitor. It is not about the fax devices. It is about all the thyristors. This is part of the thyristor protection circuit. We require to put capacitor across the thyristors, that means parallel to the thyristors, to reduce the DVDT rating of the thyristors. If we actually put thyristors in series, then it will cause high DVDT, because if the capacitor is discharged, and thus it will cause a problem, and it may be actually damage the thyristors. And for this reason, while we have to be very much cautious actually while handling the thyristors require to be put into the parallel with the capacitor. And good afternoon, Dharmender. Please ask question. Dharambi, sorry. Please ask question. Good evening and good afternoon to all of you. Please ask question. Okay. Let us take another questions that was asked in a forum. I am trying to answer it here. What it meant by the dynamic reactive power support? This question was asked in a forum. So I wanted to answer this question. By this time you prepare your question and type it, we shall take one by one. Please understand that, in the power system, in the power system, actually power line reactive power impedance capability, reactive power handling capability changes. If its value near to close to the surge impedance or equal to the surge impedance, it doesn't take or consume any reactive power. But below which it is a capacitive and it is actually the it is not loaded properly, then it will be a capacitive time loading and it will be actually essentially boost out the terminal voltage. And but when loadings comes, essentially this actually same transmission lines becomes inductive, and thus you will have a problem of actually sag, same line. And this, what you have asked basically in the forum is that actually dynamic reactive power support. This will ensure actually if this supply changes, if this actually loading changes, and all of a sudden huge loading comes into the picture, then all of a sudden this actually transmission line goes to the capacitive to the inductive, and we require to support this this actually we require to support this the reactive power, and that will change dynamically as the load changes. So for this reason we require to make it dynamic, and it has been done by actually DVL most of the cases. Next question was asked in a forum that what is the use of inductor in parallel to the SVC. Of course, we understood that our power quality problem that mostly we have a negative VAR, that means the inductive VAR. So why we put also an inductor? Generally, these capacitors are in a modular in the nature. It has been described into the class very well. So let's say each capacitor, if it is switched on, then it will give you a actually capacitive VAR of 2 MVA. You require to compensate, let's say 13.6. Then how will compensate? Then you require to operate rather 14 7 such actually capacitive SVC that will give you the actually the rating of 14 MVA. But essentially, you require a 13.6. How you will give it? What you require to give it? You require to actually give, but this you have to subtract 0.4 from this 14. Ultimately, then by this actually thyristor control devices with the inductor, that will give rise to the remaining 0.4 VAR that will give exactly the precision required to compensate your reactive power. Okay, any questions? Okay, thank you actually for your questions. The question is how the rating of the fax devices can be calculated. Now rating means actually there are switches and there are actually passive elements like inductor, capacitor. I request you to actually specify actually the device which you are looking for. So let's say you have not, since you have specified, let's say case of the STATCOM. How you will actually specify the rating of the switches of the STATCOM? First take that. So of course, actually when you are taking a STATCOM, so it's actually reactive power handling capability has been actually we have calculated, and you know that maximum reactive power handling capability is some MVR or kVR. And from there you know the voltage rating of the line, and thus you know the current rating. So of course these thyristors, if you are made by the thyristors, it will have a different rating. If you are made by GTO, it will have a different rating. Now if you consider that you have made it by GTO, now actually you have to calculate its average and the RMS current rating. And you will take a factor of safety. It is generally 20% more, and thus you get a current rating of the devices of this STATCOM, and the voltage rating also, you require to have a same voltage rating. Now, first of all, once you are talking about the D STATCOM, so you have basically the you have basically the Q STATCOM rating and the P STATCOM rating. So from the P STATCOM rating, essentially you can calculate the value of I and V, and from there actually you can actually find it out what will be the voltage and the current rating of the different switches. And apart from that, if you wish to calculate the capacitor's value of the STATCOM, then you require, of course, the voltage rating of the capacitor has to be the same of the actually double of the switches, because it has to sustain the whole voltage. And now how you will calculate the value of the capacitor? So you have to calculate with the form of inertia, because it gives you a inertia. Detailed derivation can be discussed into the forum, because I don't have any tool to actually write it here. I can only talk. So we can actually post this discussions into the class. Please note it down. Actually, we shall show that actually how to calculate inductor and the capacitor of the STATCOM. This will be posted in the coming forum soon. Huh? Is there? Okay, it is already been there. You can refer it. Any other questions? Okay. Till another question comes, let us take another questions from this actually from the forum, which has been asked that how can we know this question is actually, question is little bit language problem is there. How can we know how much capacitive reactance has to be connected in the series line? So, actually based on your different parameters, you have actually a computer that will calculate the required MVR. So this will be the required MVR at a particular moment. You will, okay. And from there you can tell us about the pattern of the external question, the questions. It will be online questions, online exam. For this, you will have a MCQs. So you have a multiple choice questions, followed by you have a breakup, that is actually 25% will be actually MCQ, and 75% you will have a numerical aptitude type. So there actually there will be a blank given, like you may actually ask to calculate what should be the alpha of a firing angle of a thyristors. Just you have to write that number. Everything has been written, so that actually you can be actually you don't have to enter in a alphanumeric number. And all those questions, please note that will be numerical. For this reason, you solve the assignment very well. All the questions will be from this assignment only. Sorry, most of the questions will be from the assignment only. Should I take another question from the forum, or I'll wait for your questions? Please ask questions, Yes, you can take it from the forum. Okay, I can take it from the forum because there are so many questions was asked, and I have already given answer of the most of the questions. So I have jotted down actually few questions. So one thing was asked, how to calculate value of the series capacitor of the SBC. So this is, since there is a derivation type questions, we have uploaded the solution in the forum. Now next question we have received, that is, what is the use of the inductor in the parallel SBC? We have discussed it, and thereafter why thyristor is not used, thyristor is not series connected to the capacitor. That means actually it is connected in parallel to actually reduce the dividity across the thyristors. And thereafter there is another question, how can, there's little bit problem in English, please pardon me. This question was actually formed in wrong way. How can we know how much capacitive reactance has to be calculated in the series with the line? This question is same, how to calculate the series capacitor. So we require to form this actually I and V, and we require a desired power to be flow from these equations. Actually we know how much actually capacitive kV are required to be injected, and from there actually we will calculate what should be the amount of the capacitor added into the series SBC. And same way, this question number 5 and the question number 7 are the same in my case. So question, how to calculate the series capacitor and how we know the capacitive reactance. This two actually will have a same answer. Now next question, it has been put to the forum, was injecting V by I by shunt. Actually question, actually he or she willing to ask was voltage or current, what is injected by voltage and current by the shunt and series controller. Of course shunt inject current and the voltage is injected in series by the SBC or the current control devices or UPQC. Now next question was asked, very open question, that is, what is phase angle regulator? Phase angle regulator has a unique thing that it can actually inject power by actually, you know that sending end power, power transmitted by the transmission line equal to sending end power, receiving end power by X into the angle between them. It controls the flow of the real power by changing the angle. So it has a benefit of that, it can actually send same amount of the power of its peak power, irrespective of the actually the delay angle. So this is the one of the utility of the power angle regulator. Now the next question was put into the forum was whether the line voltage is unipolar of the bipolar. Line voltage is unipolar. Now another question was asked, that is a very open question. What is diode clamp multi-level inverter? You know, we require, basically we can get into the philosophy of these questions. Why actually there are three, why we require multi-level inverter? First of all, why require multi-level inverter? Because we have to connect into the at least a distribution network of 6.6 kV or another voltage. So present day switches doesn't support that high voltage level, and to actually use in that voltage level we require the multi-level inverter. Another advantage of the multi-level inverter is that, you know, it will inject the less harmonic into the system, because you can split it, this is your DC bus voltage, into the levels of the switches you have actually put into the pictures. So you have option to put, let's say, 3-level inverter, plus VDC, minus VDC, minus VDC by 2, or plus VDC by 2. So you can actually accurately put actual voltage required by you, and thus what happen in case of the 2-level inverter, since there is a difference, the difference will be actually filled by the harmonics. So you have a less content of the harmonic, and for this reason we prefer the multi-level inverter. Now we have generally three kind of multi-level inverter. Broadly, one multi-level inverter is basically that diode clamp multi-level inverter. There are many actually diode clamp multi-level inverter will thereafter we have a capacitor clamp multi-level inverter, and thereafter have a cascade H-bridge multi-level inverter. Cascade H-bridge multi-level inverter will have one big disadvantage, that it requires an isolated DC source for each of the H-bridge, but since it is a modular in structure, it can be increased to the any high level you want. But in case of the diode bridge MLI, there is a very big advantage that for the 3 level and all those level, you did not have to balance the capacitor voltage actually, and thus the control system is quite easier. This is one of the biggest advantage of the diode clamp MLI, but the number of the component count increases drastically in case of this actually the diode clamp multi-level inverter. It is actually, if the M is the level of the inverter, the number of diode required is M minus 2 into M minus 1. So for the higher level, actually we don't prefer diode clamp multi-level inverter. This is little briefing about the diode clamp multi-level inverter. Achha, another few questions we get it from the forum, so I wanted to discuss it here. So we have actually talked about UPQC and that is unified power quality conditioners, and unified active power conditioners. That is basically, and we have another question. What are the question we had? One was UPQC. No, that's fine. Okay. Achha, another beautiful, okay. So Anmol has asked a question, can we use neutral to earth wire? See, can we use neutral to the earth wire is one side of using wire, providing zero potential to both. Okay, you require to understand, you know, there are two issues. One is earthing, another is basically, you know, but this question is not part of this fax devices. Anyway, you are basically this is a part of the question of the power system. So, but still, I just brief you a little bit. There are two issues. One issue is actually earthing, another issue is the grounding. So, grounding is an issue with this actually when the neutral point of the star connected system you have grounded with the inductor, resistor or something like that. And earthing is generally done in a machines where you may not, you don't want that actually the operator touches this different element of the machine should not get a shock. So, actually I assume that your question is, can we use a neutral and the earthware as one instead of using to providing a zero potential for the both. So you require to understand what is earthing and what is grounding. Grounding is grounding essentially it is done that shorting of the neutral, and earthing is done to keep zero voltage of the part where you don't want that any high voltage, because you may actually touch or the operator may touch. So these two has got a different purpose. Another good question was asked in a forum, that was the calculations of the time of the multi-level inverter. So that is basically what should be the length of the vector, and problem lies two different book has actually two famous scientists actually uses two different convention. One is by LiPo. LiPo actually used the full length of the voltage vector of the space vector modulation is basically VDC into root 3 by 2. Please form the question. What was the question? I think, actually, this question is in Ben Hu's book, if you refer, you will find that maximum length of the vector, let's say you are injecting the phase A, that is 110, or in that Ben Hu's book writes P00. So in that case, actually the length of the voltage vector is VDC by root 3. But in a LiPo's book, you can find it out that that's what the convention we have followed. That is actually VDC into root 3 by 2, basically the value of the maximum value of the voltage. Please consider the length of the voltage vector as VDC into root 3 by 2 or 0.866. Anyway, actually we have already given the answer, so I want to have a clarification more. That is called the power invariance. In LiPo's book, actually there is no power invariance, and here in the Ben Hu's book there is a power invariance actually. So you have to multiply the power invariance if you follow the principles of this actually the Ben Hu's book. Any other questions? Can you get it? Any question from the forum you can recall? Any other questions they ask? I can see 5 people are watching. Please ask questions. Acha, and there is some clarification in some books. You will get the common term is UPQC. and that is called the unified power quality conditioner. And some book will write UPAC, that is unified active power conditioner. So both are basically the same only, and it is just the nomenclatures are different. Okay. Please prepare questions, then only we can discuss it better. Now we can discuss something, some question on reference generation technique also there, no? Huh? Now, okay, so we got another question, sir. Improve for the improvement of the voltage stability of the system, which device should be used? Okay, there are, this is very open questions. First of all, if you have lot of money, then actually you will go for UPQC, since actually it will give you a total solutions. It will give you a total solution of the voltage sag, voltage swell, flickers, as well as the stability, and otherwise also the current part also. But if you have a limited resource, then we have to observe there what kind of actually problem is predominating. So generally, considering the case that triple SC is preferred of all the cases for the better stability. And if you have actually we use triple SC for actually if you have a problem related to the voltage. If you have the problem, if you have a problem related to the current, and generally it is the STATCOM. So STATCOM will provide actually the better solution in this case, and it can provide the stability, it can provide the damping, it can actually increase this actually the voltage sag. But one of the disadvantage of the series shunt compensation that it cannot increase the real power handling capability of the line. So now we have to see what you require. Now, if you are talking about stability, most of the fax devices enhances the stability. But generally the stability is basically, we will have a predominant case basis, because what happens when you try to increase the power line handling capability is and assuming that most of the line are inductive in nature, you insert a series capacitor into it, and thus what happen, you effectively reduces the line impedance, and that reduces the stability. But and from this point of view, actually STATCOM is better for the shunt compensation. We should consider fast to STATCOM to increase the stability. Any other questions? Well, now I can see the number of people watching is 11. So only actually 2 persons is asking questions. So I expect that actually more and more questions. We have to answer it. No? Hmm? Okay. Any other questions from the? Okay. Whether the line voltage is unipolar or bipolar. Now, definitely questions comes which line voltage. We want basically the line voltage to be the unipolar for less harmonic. We want, and for this reason, we actually use a unipolar PWM to get this line voltage. Basically, you are talking about in a power electronics 120-degree mode of conduction or the 180 mode of conductions. Is it from that context? Please actually refer which actually bipolar. If in case of the PWM, if it is a unipolar, then line voltage required will be the unipolar. And we prefer it required to be unipolar, and you will find that actually THD content will be lower. Okay. Actually, uh, how to calculate the value of the series capacitor, right? So this, I don't have anything to write it here, but what I can say is that you have to calculate by actually first of all you require to it depends on what kind of system. If it is a two machine model, that means you got a source, you got a transmission line, you got a load, and there you will can calculate the what should be the desired level of the reactive power compensation. From there, you require to first compute what is your kVR or the MVR you require to compensate. From there, actually, it is quite easy. Once you know that value of the kVR or the imaginary power required to be injected, and you know the voltage rating of it, and from there you can calculate the value of the capacitor. So first thing is that we require to calculate the reactive power rating of this two machine model. But there is a challenge involved in other cases when generally it is a simplified model. In practical cases, you have a different kind of bus system, and in a bus system, you will basically go for the load flow study. From the load flow study, you will actually see that what is the actually value of the P and Q, that is real power and the imaginary power in different buses, and what is your desired P and Q of those buses. And definitely, from this, so let's say your actual value is the QREF, and actually at this instant you are getting, please understand it is dynamic, and you are getting actually Q. So that actually your capacitor at that moment required to inject, that is QREF minus Q, and this is the value you have to inject. You know the voltage value, and from there you will calculate the capacitor. But please understand, this value will change dynamically. Why? It may be that moment sag has occurred, so that value will change. So accordingly, actually your value of the capacitor will be keep changing, and no static solution will give the results. Okay, thank you. For another question from Prasant. Sir, can the series compensation affect the performance of the distance relay connected to the source side during the fault system? Okay, please note that actually distance protection is not the part of the curriculum of this course. So of course, that is in general I am telling you, basically no, it will not happen. Basically, actually what you were saying essentially, say sending end voltage is basically V1, receiving end voltage V2, and you got an impedance X. Then you are sending the power of V1 into V2 by X into sine delta. And now you require to change the power handling capability of the line. But what will happen then? You are basically actually reducing the value of X, and thus current gets increased. But you will be within a limit of the fault current. So, and the relay should be able to distinction between the increased current due to the fax devices and the actual LLG or LG fault. Any other question? I got few interesting questions in this forum. Thank you for it. Okay. So now we got another question. What is meant by dynamic reactive support? Okay. Please understand that our power system is dynamic in nature. Source, actually transmission line will have its own impedance, that is called actually the surge impedance of the uncompensated line, that is under root by LC, and that value is also not constant and it will change if the line is overloaded, and if it will change line is underloaded. So if it is underloaded, it will be more capacitive, and thus we will have a positive power. All of a sudden it may be loaded and then it become inductive. So what happened previously, once this actually was underloaded, you required to inject maybe the negative bar to maintain the power factor required by you. But all of a sudden, let's say at 4 p.m., consider the case at the 4 p.m. and the 6 p.m. Now, let's say around 4 p.m., you may not have much power consumptions. And if you're the eastern part of the country, by 6 p.m. we got an evening right now, and you have switched it on all your lighting load, and all of a sudden power consumption has increased. Then what will happen in that case? Actually, all the power, all of a sudden load has increased. So which the transmission line, which was previously capacitive, will become inductive. And then we require to support, since previously it was a positive, you require to inject a negative bar. Now you require to inject a positive bar to compensate the required power factor. And it has to be done dynamically. For this reason, it is called actually dynamic reactive power support. Okay, this is the same question. Sudhir, please specify actually what is the TQ. Let him specify, otherwise I cannot take that questions. TQ can be anything, we have so many assumptions on TQ. No, please specify what you mean by TQ. Okay, thank you. Okay. I thought that you were asking any questions. I am not habituated to the chatting, so that code I don't understand. Okay. So what is the difference between UPFC and UPQC? So one is, of course, if you expand them, one is one is actually power flow. First U stands for SEM. So one is power flow conditioner, another is power quality conditioners. UPFC generally used in a actually high voltage rating, mostly actually to control the flow of power, and generally UPQC is being used in the distribution network for controlling or ensuring good power quality to the consumer. So this is the basic difference. UPQC is popular in a distribution side, so that any disturbances of the voltage and current get nullified and the consumer gets a quality power. So for this reason, what is the power quality is an issue, and all this power quality is an issue of the distribution network. Thus, UPQC is in a lower voltage distribution network, and where UPFC is connected in a actually the transmission network, and sometimes in the high voltage distribution network, where you require to actually control the flow of power from one line to another line, and also ensure good quality power also. Thank you. Okay, let us take Siraj questions. How to ascertain the size of the compensation? This is little quite open questions. Now, actually, this is a designer task. You require to study historically a site, and we have to see that basically the compensation. Generally, we consider we consider a circle of 0.5 per unit radius. So that if this is power quality handling, if it is base value is 100 megawatt, you should be able to compensate 50 megawatt of power and 50 megawatt of kVA or something like that. We consider 0.5 of the base value for the compensation. Thank you for your questions. I think he's asking this, no? Huh? But of course, you can increase the size of the radius, and that will be a specific design, but most of the cases we consider 0.5 as of its base value for compensation. Phase angle calculations, please actually elaborate. Phase angle calculation is basically that is done how you will calculate phase angle. So these has to be calculated, because if you know that you are generating the power of this megawatt, and you require to power to be some megawatt. So you know that actually sending end power and receiving end power has got relations, and this relation is governed by basically the power, the angle between them, and due to the natural line you get some value of the delta, and thus we have to add some value sigma to it, and now questions comes. There are two things. If it's a two machines model, you can actually find it out that this way, and if it is a bus system, then IEEE has a different kind of bus system. From the bus system, you have to follow the load flow analysis to calculate the phase angle. Okay, next question is, how much percentage of efficiency voltage can be improved by using the fax devices? Okay, that's what I'm saying. Generally the circle of injection is considered 0.5 per unit, but there are many exceptions. 0.5 per unit, that means actually you can we consider there are different kind of voltage sacks. One is basically blew out, that means voltage has gone up. Thereafter we can have a brownout, voltage has gone down, and you have actually voltage, it is blackout. Of course, if it is blackout, fax will actually, if it has been blackout, fax has nothing to do. In case of the brownout condition, depending on what kind of fax devices you are using, because if you are using STATCOM, its power handling capability almost independent of the voltage sag. So it can use what it can actually use the compensation up to 0.8 per unit. But using a passive devices, you will find that you are restricted to the compensation of 0.5 per unit. Okay. DVR is mainly used for the transmission. DVR is basically used. DVR is basically the part of this voltage part in the, you can say, in UPQC. Okay, that is DVR. So essentially, it is used to ensure good power quality in the distribution network. So you can say that DVR is used in the distribution network. Okay. How the transient stability of the system will be improved? See, there are fax devices will have actually some few conditionality. Before fax devices also, we used to actually improve our power quality problems by inserting capacitor. But what used to happen when you insert a capacitor, there is a problem of the transient. So we require to ensure that the system inserted without transient free, and there is a logic. So when you can insert a capacitor, so when it's actually the line voltage of the capacitor and the voltage across the capacitor are the same, then it will not give you a transient. So this kind of actually seamless operation is possible with the fax devices, and thus it will increase the transient stability. And apart from that, you can go by equal area graph, and there you know that by increase it can increase the power handling capability of the line, which was previously actually P. It can be 2P, 3P depending on the kind of series compensation you are looking for. Ultimately, your critical angle has been increased. So you get more time to compensate your actually the faults or other transient, and this will ensure greater transient stability for the fax. Please refer to the equal area criteria, which has been discussed almost all the series as well as the shunt devices, and please refer those lectures. Thank you. Okay, we have just 5 minutes left, so I can take, I think, 2 questions. Please ask as soon as possible because another colleague of mine is waiting after that. Huh, 5 minutes left. Oh, fine. Let's see. Thank you. Okay, we got another question. I think I can take this question. What is the recent research area in the fax controller? Okay. This concept is huge, Nowadays, actually, with the penetrations of the harmonics, now we have a load flow, harmonic load flow. And not only now, actually, the in a bus system, where you will place the fax controller and which type of controller, this is one area of research. And that has got a huge potential. And apart from that, this power, we can add one other problem like country like India is facing, that is basically peak power management. Fax devices can actually ensure good peak power management with the integrations of the renewable energy with the fax devices. So STATCOM can be integrated with the solar panel, and ultimately it will actually inject also the real power into the system. And these kind of combinations of hybrid fax with the renewable energy has got a huge potential. Okay, this can be the last question, I think, that is why distribution site losses are more. These are actually two types of, this is basically, if you are asking this question, we require to understand two things. One aspect is the commercial metering, another is basically the statistical metering. If you consider this commercial metering, that means actually how much this utility has been built, there are so many issues because there is a current theft and all those problems are there, and these are being reflected into the distribution network because no one steals power into the 11 kVA network. People steal power into this actually 4-1 network. This is one of the biggest channel in India having the pilferage of the power, and thus makes you the losses. And since it has been not planned accordingly to the pilferage, and mostly due to that, distribution losses is more. Okay, let's take a last question. We have to say goodbye to all of you. Thank you for with us. The last question is, can we put SBC at the weakest mast of the system for managing congestion? Answer is yes, and that is very much required to actually avoid congestion. Thank you so much indeed. We thus close these sessions. Thank you for your attention and thank you for asking very nice questions. All the best for your online exams. I hope all of you do well and come out with the flying colors. Thank you.